Hello and welcome to section 7.2. In 7.2 we're going to learn about the converse of the Pythagorean theorem. This allows us to determine whether a triangle is a right triangle or not. And then also, if it's not a right triangle, we're going to figure out if it's obtuse or acute. Here are the solutions for 7.1. If you have any questions on those, please let me know. And here is our converse of the Pythagorean theorem. So you're going to notice it says if the square of the length of the longest side of a triangle is equal to the sum of the squares of the length of the other two sides, then the triangle is a right triangle. They don't say leg and hypotenuse because you don't know if the triangle is a right triangle. Leg and hypotenuse, of course, only apply to right triangles. So that's why the wording is a little goofy here. All right, so tell whether a triangle with the given side lengths is right or not. We're just going to apply the Pythagorean theorem here. 4 squared plus 4 root 3 squared equals 8 squared. I'll put a question mark here. Make sure that this here is the longest side. Make sure you identify which side is the longest there. So 4 squared is 16. 8 squared is 64. And then we have this 4 root 3 squared. So 4 root 3 squared is 4 root 3 times 4 root 3, which is 16 root 9, which is 16 times 3, which is 48. So that's what that looks like there. And so this one does work. 64 equals 64. So this would be a right triangle. Here I have 10 squared plus 11 squared equals 14 squared. I think it's 256. I'm going to double check. 196, not 256. Okay, and so that's false. So that would not be a right triangle. Here you have 25 plus 36, and the square root of 61 is 61. Or the square root of 61 squared is 61. And so you have 61 equals 61, so this one would be a right triangle. So there you go. These two theorems here, 7.3 and 7.4, determine if it's not a right triangle. It tells you if it's acute or obtuse. So if c squared is less than a squared plus b squared, then it's acute. If c squared is greater than a squared plus b squared. My hint or my suggestion is to put c squared on the left side. And the reason for that is because less than you think of acute, small, okay, and greater than you'd think of obtuse. So it just kind of flows that way. It makes a little more sense. Okay, so we're going to tell whether it's a right triangle, and if it's not a right triangle, we'll identify if it's obtuse or acute. So we have 9 squared is 81. Actually, I'm going to do the c squared part. I should follow my hint. 3 root 34 squared. We'll put a box here. And then we'll do 81 plus 225. Okay, so 3 squared is 9 times root 34 squared is 34. So 9 times 34 is 306. And 306 is, I'm going to do 225 plus 81. I think they're equal. They are equal. Okay, so this is a right triangle. And then here I'm going to do 26 squared. We'll put a box here, and then we'll do 14 squared plus 22 squared. So 26 squared is 676. And then 14 squared plus 22 squared is 680. And so we have less than. So c squared is less than a squared plus b squared. So that would mean it's acute. Okay, can the segments form a triangle? If so, would it be acute, right, or obtuse? Now, the thing is, when you're doing these questions, you want to make sure that the 3 side lengths actually make a triangle. And so what we need to do is double check that 4.3 plus 5.2. The 2 shorter sides must be larger than the third side, or the longest side. So the 2 shorter sides must be greater than, the sum must be greater than the longer side. And this gives me 9.5. Okay, so yes, it is a triangle. Okay, now we'll do c squared, 6. Okay, so I'm going to do 6.1 squared, put a box here, and then I'm going to do 4.3 squared plus 5.2 squared. So 6.1 squared is 37.21, and of course I don't mind if you use a calculator for this. I'm doing most of this video with a calculator in my hand. 4.3 squared plus 5.2 squared is 45.53, so this would again be another acute triangle because c squared is less than a squared plus b squared. And that's all there is. There's some far-fetched examples. I can talk about these in class. The book always likes to make real-life examples. Not that anybody would ever do this or not, but there are applications to this. Here's your assignment for 7.2. I made these two challenge questions. They're kind of neat. And then a hint for 27 and 28 is opposite reciprocals and the distance formula. Thank you guys for tuning in, and I'll see you in class.